Welcome to lesson 6-7, which is on inverse relations. An inverse relation is essentially this. Where you've got two variables that are related to one another by some equation. So one of them is your input, and then you plug that in and get an output. Well, for an inverse, all you're doing is getting them switched around so that you're rewriting it so that the other one is the input instead of the output. I start us off with an example that hopefully looks familiar to you. I've got the Fahrenheit to Celsius conversion here is what this is. And what I'm going to do here is just make a little chart using these numbers, -13, -4, 5, and 14. And I'm plugging them for F. I'm saying F is my input. Hopefully look at this going, hey, it makes sense to plug in for F because that's got all the numbers around it. And that'll give us the output that we're looking for. If you plug in -13, you're going to go -13 minus 32. That's -45. And then 5/9 times -45 is just -45 divided by 9, which is -5. And you get -25 when you multiply 5 and -5. Why do I use such weird numbers? Well, they're going to come out nice. If you plug in -4, you go -4 minus 32 is -36. And we take that times 5/9, so I'm just going to divide first, and I get -20. Well, as you go through this, you should notice that there's a pattern. The pattern on the left is the numbers go up by 9s, and the pattern on the right is the numbers go up by 5s. So when you plug in 5, you should get -15, and when you plug in 14, you should get -10. And that should make sense because this up here, people, is a linear function. And linear functions have slope, and the slope is 5/9. That means that you have a rise of 5 and a run of 9. And that's what's happening. I'm going up by 5, going up by 5, and every time I do that, I go up by 9. So there's just a little linear review for you right there. Well, now what I want to do is rewrite it so that it's Fahrenheit equals. So this one up here, if I know Fahrenheit, I can tell what it is in Celsius. So if I was up in International Falls and it was 13 below, and then I go to cross the Canadian border, they would report it as 25 below because it changes to Celsius when you get up there. So right now what I'm going to do is rewrite this so that, F is a log. I'm going to start off with my equation of C equals 5/9, F minus 32. To get the F alone, the quickest way to do that is to multiply by 9/5 and then add 32. So there, if I know it's Celsius, there I can find Fahrenheit. So if I was 10 degrees Canada, 10 degrees Celsius, I do 9/5 times 10, that'd be 18. 18 plus 32 is 50, so it'd be 50 degrees. That's what we would recognize 10 as. We would recognize it as 50. Okay, well, I'm going to use this. This is the inverse function. What I just found is the inverse function. I switched the output and the input. I made the other letter become the input. So I'm going to go ahead and use that chart, and I'm going to plug in what I had for outputs up top. For -25, -20, -15, -10 Celsius temperatures. And when I plug them in, I better darn well get what I got up there for Fahrenheit temperatures. There better be that 1-to-1 relationship. So when I plug in -25 right here, I'm going to get -5, I get -45, I add that to 32, I get -13, which I should have expected that. This one has a slope of 9/5. It's linear. So the rise is 9, so I'm going to go up by 9s. And the run is 5, so I'm going up by 5s every time. Basically what I'm showing you here is to find an inverse, if I give you a list of numbers, here I've got this list right here, and I had that list up top there. These are inverses. First part of your assignment gives you a list of numbers. Said find the inverse. All you have to do is switch the x and y's. So if I give you this list right here, you switch x and y, and there's your inverse. It's as simple as that. What does that do graphically? That's what I have at the bottom. Unfortunately, graphically, I've got this. I don't have 25 numbers. I'm going to have to go by 2s to fit it on there. And I'm not going to do all of them. I'm going to do negative 20, negative 4. I'm going to do negative 15, 5, and negative 10, 14, and just show you the relationship between those and the inverse one, which is just the reverse. So there's a relationship between that and its inverse. Graphically. What is that relationship? Well, let's go ahead and graph negative 20, negative 4. And if I go by 2s, that means I have to go 10 left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 2 down. So there's that point. The inverse of that is negative 4, negative 20. And that's 2 left, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 down. So these two right here are inverses of one another, these points. Let's go to the next one. Let's do negative 15, 5. Negative 15 going by 2s would be 7.5 left. 1, 2, 3, 4, 5, 6, 7, 7.5. And 2.5 up. And there. The inverse of that is 5, negative 15. That's 2.5 right. And 7.5 down. 1, 2, 3, 4, 5, 6, 7.5. Should be right in the middle. Those right there are inverses. One more, last one. Let's go with the negative 10, 14. That would be 5 left. 1, 2, 3, 4, 5, and 7 up. 1, 2, 3, 4, 5, 6, 7. The inverse of that, 14. Be a negative 10. I don't think I got my negative there. Fix that. 14, negative 10. That would be 7, right? 1, 2, 3, 4, 5, 6, 7, and 5 down. 1, 2, 3, 4, 5. Those are inverses. I'll circle those. Those are inverses. Well, there's a relationship between inverses graphically. And in geometry, you talk about certain reflections, but you don't emphasize the reflection that these points represent, and here it is. These points are reflected over y equals x. That's important to note. Okay? Inverses are reflected over y equals x. Inverses are reflected over the line y equals x. So these two here, they should be equidistant to y equals x, and then they should hit at a 90-degree angle. These right here should be equidistant to y equals x and be a right angle. So that's how inverses are related graphically. To find inverses, all you have to do is switch m and n. We had students take a plan test, and one of the question was, reflect mn over the line y equals x. Well, the correct answer is simply nm. Just switch them around. Okay? Well, let's get to what we're actually going to be doing here for an assignment. We're going to find inverses, and here's the way to denote it. You put f with a little negative 1 up there. That doesn't mean 1 over f of x. You'd have 1 over f of x, you'd actually go f of x and then take that whole thing to the negative 1, or like that. That would put 1 over f of x. This just means the inverse. How do you find an inverse? Very simple. Switch the x and y. So make the other letter the input, and then just solve for y. Get the output alone. Some questions you'll be asked are, is your original graph a function? And we go back in time and we go, oh, we could tell if it's a function by the vertical line test. Does every x go to the same y? You know, if I have same x's, do they go to the same y? The problem was if you had different x's, same x's going to different y's. That doesn't make any sense. So we said a vertical line test takes care of that. You know, in order or a table, if I had 2 and I said it goes to 3, when you plug in 2, you better get 3 again. Otherwise, it's not a function. That doesn't make sense. If I tell you to plug in 2, you should only get 1 answer. Then the most important new question is the inverse a function? Is the inverse a function? Well, you can simply look at the graph of your original function and use what's called the horizontal line test. So if you graph the original function and a horizontal line goes through more than one point, then the inverse is not a function. Okay, so let's do a couple examples here. Find the inverse of y equals 3x minus 5. F of x equals is like y equals 3x minus 5. Well, first let's investigate y equals 3x minus 5. It's going to be a line. Well, let's say there's a line. It goes up. And that itself, all lines are functions. And you could say the vertical line can't hit more than one point. Okay, so it is a function. We can find domain range of that. It goes forever left and right, so the domain's all reals. It goes forever right, up and down, so the range is all reals. Remember, domain goes with your x's, range goes with your y's. Now we need to talk about the inverse. How do I find an inverse? I simply take this and switch x and y and solve for y. So add 5 and divide by 3. There's the inverse. Is that a function? Well, you can tell me it's a function in 2 ways. You can tell me a function because you know that's a line, and it would pass the vertical line test. You could actually graph this over here and say it passed the vertical line test. But more easy to say is that the original function right here passes a horizontal line test. So if you've got a horizontal line and your original function, if you can't hit more than one point, that tells me that this is a function. Because the original function passes the horizontal line test. That one HLT, you might want to go up top there if you're going to use HLT. Otherwise, write horizontal line test. The other thing we need over here is domain range. Again, domain goes with your x's, range goes with your y's. So if you think about it, to get this over here, all I did was switch x and y. So all that means is I got to switch these two right here. If I switch x and y, then the domain and range switch. Well, if I switch them, nothing changes. In this case, anyways. So you get all reals, all reals. All right, let's go on to the next one. Find the inverse of y equals... What kind of equation do I have here? I've got a quadratic. This is from first semester. That's a quadratic function. Can we graph that quadratic? I hope so. It has a vertex at 3, 1. If you plug in 4, or if you go 1 right, you're going to have to go 4 up. So it has that point there as well. It has 4, 5. It also has 2, 5. This is what the function looks like. The function itself has a domain of all reals because it goes forever left and forever right. The range is a little different, however, though, because it doesn't go any lower than 1. 1 is a minimum point. So the range is all reals greater than or equal to 1. I can answer the question about is the inverse a function right now. The inverse is not a function. I know the inverse is not a function because if I take a horizontal line over here, I can hit more than one point. So I don't even need to graph the inverse itself. I can just look at what's over here and say, hey, a horizontal line hits more than one point. So no, fails horizontal line test. I can also tell the domain and range of my inverse. The domain and range is simply these two switched around. So the domain is all reals greater than or equal to 1, and the range is all reals. What is the inverse relation? Again, it's not a function, it's a relation. What is it? We can take this. I'm going to create a little bit more room here. Oops. Woo. Start there. I just want to get these. Get these. Oh. Sorry about that. There we go. Get that out of here. Having lots of fun. Good times. Actually, then we can put those over here because that goes with our original function. All right, so what do I do with this? Switch x and y. And get the y alone. Subtract 1. Divide by 4. I've got y minus 3 squared. I like to do reverse order of operations. So I'm going to deal with the parentheses last. So I'm going to square root it this time. So I'm going to get y minus 3 equals, don't be that guy, put plus or minus, the square root of x minus 1, and I'm going to simplify the square root of 4 into a 2. There's one more thing to do in order to get my inverse. That would be to add 3, so it should go to y equals 3 plus or minus square root of x minus 1 over 2. There's the inverse relation. It's a relation. You couldn't get that graphed in a calculator. You couldn't put 3 plus or minus like that in our TI-84s. But what you could do is you could trick your calculator. You could put 3 plus on a y1, 3 plus square root of x minus 1 over 2, and then on y2 put 3 minus square root of x minus 1 over 2, and your calculator will actually graph what this looks like. Okay, so I think I've answered everything here. We had the main range. We got that from our beginning. Here's what my function looks like. I do want to show you what the graph would look like, just to remind you how this works. An inverse simply switches the coordinates. So looking at my graph, remember this is 3, 1. My inverse is going to have 1, 3 on it. And remember how this right here was 4, 5? My inverse is going to have 5, 4. And remember how this was 2, 5? My inverse will have 5, 2. And there's what the graph looks like. You can see that graph itself obviously fails the vertical line test, but I didn't need that in order to come up with the fact that it wasn't function, because I could just use the horizontal line test on the original parabola. All right, example 3. Here we're just going to find the composition of inverses. That means take an inverse and plug it into the original function and vice versa. So we're going to have like this, where I plug an inverse into its function, the beginning function, and then I take the inverse of what it started as. In both cases, you should end up back where you started, back at x. So I'm going to show you that you actually do end up at x. That's how you prove it. If I want to find this, I start with the f function. So I go 2 parentheses plus 4, and then I plug in 0.5x minus 2. Now, I did make an adjustment. I had a typo, so if you're just getting this in 2015, this right here needs to be switched to a minus. Make that switch. Now just do the distributive property. You get x minus 4 plus 4, and that's just x.
Attention, the time is now 2.
Sorry for that little interruption. Now over here, we're going to take the inverse, write that down. So on 0.5 parentheses minus 2, take out the x, and then plug in 2x plus 4. Distributive, get x, distributive, get 2 minus 2, you get x there too. So you see how it works, you get x both ways. So when you see a problem like this in your assignment, where it says just plug f into the inverse of f, and then plug in 7, okay? So this is plug in f of 7 into the inverse, you just get 7. You go back to where you started. That's all that means. Go back to where you started. So anytime you see this, you know that this right here is going to be your answer. You don't even have to go through all the work. That makes sense of that. If we go back to our Celsius thing here, so if I plug a number into a function, so let's look right here. I plugged in negative 13 into this function, and I got negative 25. So I plugged in negative 13, I got negative 25. Now you take that answer and plug it into the inverse. So we're going to take that and plug it in down here. Well, you end up back at negative 13. That's all it is. Right? Down here, we could have plugged in the 7 into the f function. So if I plug 7 in right here, I get 2 times 7 plus 4, I get 18. Now if I turn around and plug that 18 into the inverse function, right here, I get a half of 18 minus 2. Well, that's 9 minus 2, which takes us back to 7. Okay? So inverses, just take it back and forth like that. All right, sorry for the length of the video here. One last one, we can do it. I'm going to cut off, prove there's inverse right here. And just say, hey, if you see something like this, what's the answer? It's just x. You don't have to do any work for that. We're going to find the main range of the function and its inverse. Right now, you guys don't know how to graph this, so what I had the class do was go ahead and put it in their graphing calculator. And when they put it in their graphing calculator, it came out, let's see how my memory is, it came out with a y-intercept of 0.5. Just looking at the table. So graphing the original function, and I said, how about 3? And when you plugged in 3, I think you got 4.27, like that. And then I said, what about negative 3? And that was like 5.7. 1, 2, 3, 4, 5, like that. And the graph looked like this. So if you don't know how to graph something, just put it in a graphing calculator. Now, this graph is supposed to be going forever up and forever down. And it goes forever left and forever right. So just based off that, what I showed you there, I would say the domain here is all reals, and the range is all reals. And that should make sense. Is there anything you can't plug into x? Is there anything you can't third root? And the answer is no, you can third root anything. You can third root negatives, you can third root positives, third root 0. So that tells me the domain range of the inverse. And that's just switch them around. If you switch them around, you get the same thing. I haven't found the inverse yet, but I do know that the domain range is all reals. Okay, let's go ahead and find the inverse. Let's take this right here up here and let's rewrite it so that y and x are switched around. So it'll go x equals 5 minus third root x over 2. Getting the third root y, sorry. Switch x and y. Okay. Subtract 5. Got to get rid of this negative and the 2. You can do it one at a time, or you can multiply everything by negative 2. That give me negative 2x plus 10. And that give me third root y. I get rid of the negative and the 2 at one shot. And then finally, we would go ahead and power both sides to the third. So you get y equals negative 2x plus 10 to the third. And we can go ahead and leave it like that, but I'm going to remind you that you cannot distribute the 3 here to get your answer. This is not y equals negative 8x cubed plus 1,000. That's part of it. There are still 2 other terms in here that you need to find, because when you take a binomial to the third, you end up with 4 terms. We did an example like that on our last assignment, where we did that choose stuff, and it was from first semester. We did 3 choose 0 and worked our way down. You can go ahead and leave your answer like this. You don't need to expand it out. You can certainly put that in a graphing calculator. Graphically, I don't really need to put that in a graphing calculator. I can simply look at what's down here and go, well, I've got 3 points. How about I get 3 points? I just switch these around. That's how I do an inverse. 5.7 comma negative 3, that would be right in here. And 5, 0 right here. And 4.27 and 3 is right here. The graph should look like, oops, I don't know much of a bend there, sorry, like that. And as a reminder, these are reflections over y equals x. So y equals x is your axis of symmetry. That's inverses. Thanks for watching. Have a great day.